What would happen if suddenly a star close to Earth collapsed? No warning, no time. A silent event in space, capable of triggering irreversible effects here, now. Science knows this is possible, and you also know that it is not a question of if, but of when. There are unstable celestial bodies, constantly monitored, that can reach the end of their cycles at any moment, releasing forces that surpass any human containment capacity. But are we prepared for the impact, or are we ignoring a real risk that is already in motion? Comment below, do you think the Earth would survive an event like this? Or would we be just another detail erased from the universe? Because in this video, you'll discover how far the truth can go, and why this scenario may not just be theory. Before talking about the effects, it is necessary to understand what a supernova really represents. It involves the collapse of a massive star, usually at least 8 times the mass of the Sun. When this type of star uses up all of its nuclear fuel, which in cosmic terms can take millions of years, it loses the ability to sustain its own gravity. The core implodes, and in a fraction of a second, a chain reaction releases an amount of energy so extreme that it can briefly outshine the combined brightness of billions of stars. Literally, for a few days, a single supernova can be brighter than an entire galaxy. But light is just the visible sign. What really matters is what this explosion carries. Shock waves, extreme magnetic fields, and in specific cases, jets of radiation that can cross space at speeds close to that of light. This event is not just violent, it is transformative. It marks the end of a stellar cycle and the beginning of unpredictable consequences for everything around. Stars may die like this every day in the universe, but what makes a supernova relevant to us is the distance and the direction. A nearby supernova and headed our way is not a harmless hypothesis, it's a real threat. But this dynamic hides a consequence that few people know about. Not every supernova poses the same type of risk. There are 2 main categories, Type Ia and Type II supernova. The first occurs in binary systems, when a white dwarf steals matter from a companion star until it reaches a critical point. Type II ones are the result of the collapse of giant stars with masses tens of times greater than the Sun. It is in this second group that the real danger for the Earth lies. The reason is simple. Type II supernovae and their extreme variants such as hypernovae can emit jets of gamma rays, concentrated beams of highly energetic radiation. Unlike visible light, these rays cross space with almost no dispersion, maintaining their power over immense distances. If one of these jets is oriented toward Earth, the effects would be devastating, even if the explosion occurred thousands of light years away. The ozone layer would be destroyed almost instantly. Cosmic radiation would enter the atmosphere without filters. This is not abstract theory. Similar events have already left marks on Earth, visible in geological records and carbon anomalies. Hypernovae, for example, can release energy equivalent to hundreds of ordinary supernovae. They are rare, but not impossible, and the universe as we know doesn't care about what's rare. What if one of these was pointed directly at us, without anyone noticing? If you value content that challenges common sense, questions what seems stable, and reveals what the majority prefers to ignore, this is the right time to leave a like. Interactions like this show YouTube that there are people interested in real science, mind-expanding hypotheses, and unanswered questions. This is how we strengthen a community that thinks beyond the obvious, and you are part of it. Now, there is a technical detail that is rarely discussed outside scientific circles: the behavior of the Earth's atmosphere in the face of intense exposure to cosmic radiation. This is the next point in the equation, and what it reveals could completely transform our idea of planetary security. In a supernova event close enough, the first tangible impact wouldn't be physical, it would be chemical. high-energy radiation, especially gamma rays, would hit Earth with enough intensity to start a chain reaction in the stratosphere. The ozone layer, responsible for filtering the sun's ultraviolet rays, would collapse. This wouldn't take weeks, not even days. Within hours, atmospheric protection would be drastically reduced, making the planet vulnerable to direct solar radiation. Without the natural filter, UV levels would reach lethal levels. The consequences are not limited to human skin. Molecules essential for life would begin to degrade, affecting living organisms from oceanic algae to the most complex biological systems. Furthermore, the radiation would alter the electrical dynamics of the atmosphere. Cloud formation, wind patterns, and even the ionic balance of the air would be distorted. The result? Climate instability on a global scale, with more intense storms, unpredictable meteorological phenomena, and a sky that would no longer follow known patterns. It wouldn't take a visible explosion to notice the difference. The environment itself would begin to give signals, and they would not be subtle. The color of the sky would change, daylight would look wrong, and the entire planet would enter into forced adaptation. There is an invisible connection between this atmospheric transformation and a biological collapse that is yet to come. With the destruction of the ozone layer, the next impact would be direct on life. Continuous exposure to high levels of ultraviolet radiation would alter DNA at an accelerated rate. Genetic mutations would become inevitable and lethal. Cells would lose their ability to regenerate, causing failures in the immune, neurological, and reproductive systems. The human body, like that of any animal, was not designed to resist this type of constant aggression. Plants, the basis of the entire terrestrial food chain, would be the first to collapse. Photosynthesis depends on solar stability and predictable atmospheric conditions. Without this, vegetation would begin to die on a massive scale. This would not only reduce available oxygen, but would directly affect the entire ecological structure. No plants, no herbivores. Without herbivores, there are no predators. In a matter of days, the balance would collapse. Microorganisms essential to the life cycle, such as phytoplankton in the oceans, would also be decimated. This would interrupt the production of oxygen on a planetary level, further worsening the conditions for survival. We are not talking about a hypothetical long-term scenario. The first consequences could be felt within a few days, and without response time, there would be no room for adaptation. Would life resist, or are we just another fossil layer in the history of the universe? But before total biological collapse, there is another tipping point, one that involves everything humanity has built based on technology. Now answer honestly. Faced with a change that starts in the air we breathe and reaches our DNA, what do you think would determine who lives and who doesn't? I'm not talking about luck. I'm talking about standards, decisions, geographic locations, access to information. Comment below. What do you think would be the true survival factor in a scenario like this? Your answer may open paths that have not yet been explored. And here, each well-constructed theory becomes part of a larger puzzle. Because the issue does not end with biology. The next piece of this scenario touches on the foundation of everything that sustains us as a civilization, infrastructure. And what happens when it starts to fail depends not on biology, but on physics. The radiation that passes through space after a supernova is not limited to affecting living organisms. It also interacts with electromagnetic fields, electronic circuits, and communication systems. This means that the first visible targets of a nearby stellar collapse would be the technological structures that support modern civilization. Satellites in orbit would begin to fail, not from direct impact, but from interference with boards and control systems. GPS signals would become inaccurate or disappear altogether. Without satellite communication, terrestrial telecommunications networks would go into overload. Electrical networks, interconnected by automated systems, would be particularly vulnerable. Radiation waves would interfere with transformers and distribution stations. This would generate large-scale blackouts that would not be solved by technicians in the field because the source of the problem would be outside the Earth. The Internet, which depends on the stability of these networks, would become unstable. Banks, hospitals, transportation systems, and even military structures would lose coordination. The technological collapse would not be immediate, but within a few hours it would become clear the hyper-connected world had entered functional bankruptcy. Humanity, deprived of its main means of communication and control, would be vulnerable, not knowing what is happening, not knowing where to go, not knowing who is still alive. But what if, even with everything falling apart, there was still a chance of survival? Faced with a supernova event with the potential to reach Earth, the margin for maneuver would be narrow, but not non-existent. The first answer would depend on the ability of astronomical detection systems to identify changes in unstable stars. If advance notice existed, even if it was just a few hours or days, some emergency measures could be attempted. Governments with advanced technological resources might opt for immediate partial containment actions, preventive shutdown of electrical grids to avoid overload, isolation of critical data, and activation of emergency protocols for satellites and space stations. But that would only be the beginning. Researchers have been studying the possibility of artificial magnetic shields, orbital structures capable of deflecting or absorbing part of the cosmic radiation. In parallel, underground shelters with radiation protection would be reactivated or built in strategic areas, prioritizing scientists, leaders, and essential command systems. Science would play a central role, not just in immediate mitigation, but in developing long-term survival strategies. The problem is that science takes time, and time in this type of event is a resource that cannot be bought. And would you be ready to act? Or would you wait for the first glow in the sky to believe? There is a specific star that, according to the scientific community, could be much closer to exploding than we imagine. Yes, and it has a name, Betelgeuse, located in the constellation Orion, approximately 640 light-years from Earth. Betelgeuse is a red supergiant in an advanced stage of life. It is a star that has already shown clear signs of instability. Its brightness oscillates with unusual intensity, its radius expands and contracts, and spectral data show an accelerated loss of mass, typical characteristics of a star that is close to collapse. Despite the distance, the most disturbing factor is not where it is, but when it will explode. And that is an unanswered question. It could be 100,000 years from now, or it could be tomorrow. The light we see from Betelgeuse today came from there more than 6 centuries ago, which means that if it has already exploded, the signal is still coming our way. And when it arrives, it will arrive in full. The chances of being hit directly by a jet of gamma rays from this supernova are low. But the universe does not operate based on human probabilities. It follows laws that we are completely unaware of in many layers. And uncertainty is not a failure of the system. It is part of the process. There are other giant stars in our galactic surroundings that also exhibit irregular behavior. Monitoring them all in real time is impossible, and any of them under specific conditions could trigger unpredictable planetary effects. The universe does not give warnings. He just acts. This type of information does not reach the general public, but now it has reached you. Share this video with those you know who also see beyond the obvious. Send it to that friend who questions everything, who enjoys real mysteries of the cosmos, who knows that behind the apparent balance, there is something much bigger happening. Let's spread this warning among those who really want to understand what is at stake. Few have access to this type of content. You have. Make this knowledge circulate. This is how ideas that matter survive. Now, if the universe has the power to erase entire planets, what would happen if ours were swallowed completely? No chance of return, no time to react. If Earth were within direct range of a supernova, there would be no room for mitigation. It wouldn't just be about radiation or atmospheric impact. We would be inserted into a total energetic transformation. High-energy particles would penetrate the planet's core, causing thermal and gravitational instabilities that no natural system could balance. The Earth's crust would begin to disintegrate. Internal heat, driven by reactions triggered by extreme radiation, would reach levels incompatible with the existence of any geological structure. The Earth would literally melt from the inside out. No current technology would be able to contain or resist the process. And with the total destruction of the biosphere, the physical structure and the magnetic field, all that would be left would be dispersed matter. Our planet would turn into interstellar dust. There would be no recognizable traces of civilization, no time capsule, no digital signature, just recyclable atoms wandering in space, waiting for new gravitational cycles. But this scenario, although extreme, raises a question that goes beyond destruction. Every supernova generates waste that over time becomes building blocks for new stars, planets, and elements essential to life. Would this be the end of us? Or just the beginning of something bigger? In the end, the question is not when a supernova will happen, nor how it would hit us. The real question is, what are we in the face of a universe that creates and destroys as easily as we breathe? Perhaps the event will never reach us. Perhaps yes, but the true value lies in the exercise of thinking the unthinkable. Understand that the cosmos does not revolve around us, that we are exposed, fragile, passengers, and yet capable of asking questions, investigating, building theories from the unknown. Because imagining collapse is not wishing for the end, it is understanding the real scale of existence, and within it, discovering where our role lies. And that changes everything. If this kind of vision provokes you, instigates you, moves you, then this channel is your place. Being part of this is more than watching videos. It's walking side by side with ideas that challenge common sense, that expand understanding, that reveal what almost no one is looking at. Here, each question makes room for something bigger, and there is still a lot to be explored. Click the subscribe button and follow this journey with those who also believe that the universe still has a lot to say. And now that you understand what can happen when the universe decides to act, maybe it's time to find out what else could be going on without anyone noticing. Click on the video that appears on your screen and continue with me in this investigation that could change your perception of reality.